Hi everyone, my name is Niels Bantilan. I'm the Chief ML Engineer at Union. Union is a unified AI platform. We mostly specialize in helping other organizations, small, medium, large, enterprises, build data systems, ML systems, AI systems that are oriented to production grade, at scale, critical path type applications. Maybe to name drop a little bit, let's say Toyota's Woven Planet uses us for all of their autonomous vehicle data processing and model training. Stripe uses our open source product. We have an open source offering as well called Flyte. So you'll see the words Flyte and Union peppered around this workshop. So you can think of Union as essentially the company and the product that we're commercializing with the kind of foundation of Flyte. Today I'll be going through the LLMOps processes and building blocks to take RAG from demo to production. I think that the title here is a little bit off from what you might have seen in the schedule, so apologies for that. But really, the main takeaways are we're not going to do anything super fancy in terms of specific RAG techniques. We're really concerned about the systems around it so that you can reliably ship, your RAG product. And obviously, agents are all the rage right now, but I guess I would say RAG is still, if you think of RAG as kind of like souped up search engines and souped up retrieval systems, RAG is still it's gonna be around. And in fact, agentic systems will use RAG as part of a tool in an MCP server or whatever, however you implement that. So hopefully a lot of the lessons that you'll take away here, you can bring to your organizations, regardless of whether you use Union or not, or whether you have like a homegrown orchestration tool. Hopefully some of these lessons you can kind of abstract away and transfer over. A little bit about myself. Besides being at Union, I'm also the open source creator of Pandera. This is a data validation tool for dataframes in Python. I'm a core maintainer of Flyte, which I mentioned is our open source product. For folks who might not come from a traditional math or CS background, just give you an example of myself, of someone who came from biology and public health and kind of like, I guess my gateway drug was statistics, and then I got into Python programming, and then I found out kind of later in my graduate career that I really love coding. So now here I am, and I love just building open source tools, also closed source tools when needed, because you need to make money to sustain these things, unless you're like looking for grants and stuff, which is also a viable way of doing open source. Just a real quick breakdown of this workshop. I think I'm already over time, but basically I'll go over the notebook prereq setup to just get everyone oriented. You're going to have to create some accounts, and it'll take a few minutes for us ultimately to get a Union serverless account. This is a platform that you will be using today to run all of our jobs. I'll give a brief introduction on RAG and kind of just set some context here for everyone. Just quick show of hands, who has built a RAG system, either toy or in production or whatever. Like have you run code that has implemented a RAG pipeline? Okay, cool. So a few of you. So the first section kind of broke these up into 4 sections. These sections will map onto the collab notebook we'll be running today. The first section will just implement a very basic RAG pipeline, no bells and whistles, nothing agentic about it. Then we will create a evaluation data set. So I guess one of the main points I'll hammer down here as well is, if you're coming in from the ML world, evaluation metrics have always been important. How well is your system doing? Nothing has changed in this respect. It's just a little more complicated to implement evaluation metrics. You can't just do like equality matching. You can't do accuracy, you know. Or even like the traditional NLP metrics like Blue Score. Those can offer some signal, but because LLM outputs can be of varying length and of varying quality, you can have a correct answer that's very concise and a correct answer that's very long. It's harder, so we'll get into how to bootstrap this without any actual user data to just get your system ready for when you start collecting user feedback or kind of paid human labeling data, that kind of thing. Take a brief break because I think studies show that a human attention span is like 45 minutes, arguably shorter now with like TikTok and things like this. I mean, mine is super short now. It's really bad. Section 3 is about taking a classical ML approach, which is hyperparameter optimization, and kind of not retrofitting it, but transferring it over to this system, like RAG pipelines in particular. And then the last section, we'll see how we can orchestrate the entire HPO pipeline from creating your initial knowledge base and the vector store, and how to implement a system that just every time you refresh the vector store, you execute the entire pipeline from creating the eval data set to running the HPO sweeps to getting kind of like the best configuration just with kind of simple grid search. But you can see how you can extrapolate that to fancier HPO techniques. And then we'll just do a little wrap up. I do want to get a sense of just rough, let's say, just job titles here. Who here would identify as a data scientist? Machine learning engineer, software engineer, data analyst, and what did I miss? If people can.
Architect.
Okay, cool, awesome. Yeah, so a varied group of people here. Sorry?
People manager.
Oh, people manager. No, nice. Okay, cool. That's awesome. I did talk to a journalist yesterday who is a writer, but her team is like building RAG pipelines now with like vibe coding.
Vibe coding?
Which is very cool, you know. Anyway, another topic for another day. Okay, so I'll spend a little bit of time here. Really, your home base is kind of these slides. So if you can go to go.union.ai/tmls-workshop-2025, it should take you to these slides. Let me just do a quick sanity check of that. Okay, so it'll take you to kind of like the published version of these slides. And from here, you can access all the other links. The collab notebook we'll be running code off of is in this LLMOps production RAG repo. And if you click on this, this badge right here, open in collab, and zoom in a bit.
Can you bring up that link again?
Yeah, of course. Yeah. So go.union.ai/tmls-workshop-2025. Yeah. So if everyone's on these slides, also you don't have to run the code. You can just kind of spectate and let's just try to via osmosis get the material. Okay, and then once you're here, the notebook itself is accessible through this badge. So if you open that, I highly recommend going to File, save a copy in your own drive, which I'll go ahead and do. And this will just save this to your drive so you can mess around with the code cells, and you can save whatever edits you make if in case you want to keep those around. So once you're there, I'm going to hop back onto the slides. As I said, I will be giving out a OpenAI key for you to work with, since we will be just using an LLM provider today to simplify just that part of it. And I'll be giving this out through the Slack channel here, the Flyte Slack channel. So if you click on this, hopefully it should take you to, let's see, this channel here called TMLS RAG Workshop 2025. And I'll be sharing the key on this channel. Yes, someone is hungry for fresh tokens. Yeah, feel free to dump. I've tested this several times, but in my experience, there are always bugs, even though Colab is fairly stable and, should be a standardized environment. So if you have any issues, please just dump them here with the error message and like whatever code snippet you ran, and hopefully I'll be able to quickly address those. If not, apologies, and you'll kind of just have to debug it on your own. Last two things, if you don't have a GitHub account, create one please, because you'll need one to sign up for Union.ai serverless. So the last step in all of this setup is going to signup.union.ai. If you click here, you should go to a page. I'm already set up, but it should take you to a page that's kind of like a sign-on flow, and it should take you through like a GitHub authorization page and stuff like that. At the end of that flow, it should take you to this Union serverless dashboard at serverless.union.ai. If it doesn't, you could just manually enter the URL, and it should take you to the place. It'll take like 2 to 3 minutes for the account to be fully provisioned. So just hang tight if it doesn't immediately happen.
Sorry, do we have to request access to the Slack group or something? Because it's not letting me sign in.
It's not letting you sign in.
Yeah.
Oh, that's unfortunate. I should have tested this. Let me try. What if you go to slack.flyte.org? So if you try going through there, if not, let me see if I can quickly spin up an invite link. Okay.
Yeah, I think you have to go to the Flyte
it's
Slack.
Okay, so.
It's like another environment or something, maybe.
Oh yeah, I don't know how this all works, but. So you went to slack.flyte.org?
Yeah, I just Googled it, yeah. I don't
Okay. So for this, I go to slack.flyte.org, and then head on over to the TMLS RAG Workshop 2025.
Oh,
Okay, cool.
browse it, right?
Cool. So let me get started here. Try to go through this very fast. So basically, the problem setting is, every week there's a new RAG technique, even though it's been 3-4 years since the term came up. There's a basic RAG pipeline. You have a bunch of documents. You create a vector database out of it, and then at inference time, a user query comes in. You do a search over the documents based on either embeddings or some kind of, say, older traditional, I think BM25 retrieval process. You have a hyperparameter called K with top K chunks, which is these documents are chunked up in the vector database. You do some kind of cosine similarity or something like this, and you get the top 10 documents. You stuff it all into the LLM's context, and you get a response. So that's what we'll be building just now in the Collab notebook. But there's a ton. There's like Agentic RAG. There's RAG that kind of corrects itself for any of the intermediary outputs. I actually don't even honestly would have to remind myself of all the different rags, right? So, and if you do an archive search, I think this was maybe from a few months ago, you'll get 1,000+ results on different things people have done with RAG. So the question, which for those of you who've done any modeling whatsoever, training machine learning models like with sklearn or whatever, is what model do I use? Do I use a decision tree or a neural net or a random forest? And just to harken back to the good old times when models only did one thing, you know, the model's like, what do I do? It's you predict cat or dog or some finite set of classification values, or you do only regression, so you output some scalar value. And in this setting, we all know that hyperparameter optimization is one way of doing non-differentiable function optimization. So you have a grab bag of like a hyperparameter space of parameters, and this can include the model itself. And so that there's like some conditional like sampling you'd have to do if you're like picking a model family and all of its relative hyperparameters. But the main point is you're either doing some kind of grid search over some fixed number of settings, you're sampling over distributions of the hyperparameter space, or you're doing some kind of like fancier like Bayesian optimization where you have a Bayesian model selectively sampling the space for things for areas it doesn't know what the value is of that particular point, right? So apologies if this is kind of going down a rabbit hole that you're not super familiar with, but the main point is you can think of a RAG pipeline. So instead of like thinking of an ML model as the primary thing you're optimizing over, you can think of compound AI systems or compound AI pipelines that are whole systems where a model is just one part of it. Like in this case, it's the generation step that has an LLM backing it. There's like this out-of-band process that's producing this vector store, but at inference time that's kind of irrelevant. But anyway, you have different components, software components like vector databases or even Postgres that has, I think, vector search plugins now. And these also have hyperparameters, right? So top K chunks is just one of them. The retriever, the type of retriever you use is another hyperparameter. The type of embedding model you use for retrieval is another one, right? So basically, if you black box this entire system right here, you can treat it just like a machine learning model that we use to do HPO over. And if you think of even kind of just zooming into the LLM, right, you can think of LLMs as programmable via their inputs. And so if I have a user query here, silly examples like write me a haiku about a dog or something, like the prompt that you give it will change the activation patterns, which I'm kind of gesturing at through the gradient in this middle box here. Like the activation patterns will change based on the prompt, even though the input is fixed. Anyone who's worked with ChatGPT has an intuition about this, right? So the prompt is yet another hyperparameter with infinite, well, kind of constrained by the context window, but a very large search space of possible prompts if you think about it as a hyperparameter. So the parts that are tunable are, let's say, the crawler configuration. So you're crawling documents over the web. You can arguably that this is a hyperparameter as well. We won't really cover that today. There's the kind of embedding model you use. There's the chunking algorithm, as I mentioned earlier, et cetera, et cetera. So I mentioned all of these. So at each of these stages, and even the basic pipeline, there are a lot of knobs for you to tune where instead of reaching out for like the fanciest, shiniest agentic thing, it's important to try out just the simple stuff and see if that works. Because assuming most of us here are practitioners and we're not necessarily academics who are trying to publish like the best performance on a benchmark, we're trying to deploy the thing in our company to provide value for some end user. Okay. The thing is with the tools here are just the parts that you can then further fine tune, right? So if you want to go even a layer deeper from the AI system, there's the models themselves that you can fine tune against some set of documents. So the embedding model you can fine tune to hopefully get better retrieval, better semantics out of the embeddings to get better retrieval performance. And then obviously the generation model. So you can fine tune this on your domain of interest. Then there's a whole rabbit hole of requiring GPUs and all that good stuff. And that's a whole nother workshop. Okay, how am I doing? So very briefly, we'll see kind of all of this, and the code will get a little bit complicated, but just to give you an initial mental model of this, hyperparameter optimization for RAG is not that much different from if you've implemented such a system with traditional machine learning. So the main difference, instead of a kind of a training data set you start off with, let's assume it's like a SQL query away, and you kind of have to clean it up a little bit in pandas or whatever your tool of choice is. You have an eval data set, which we will kind of bootstrap using LLMs themselves, as you'll see a little later. You split them into these three: training split, val split, validation split, and test split. These are kind of training because you're not actually training the model. You're kind of doing HPO over some set of different configurations. So in this example, it's just the prompt that you're using. So in this case, you're testing out, does helpful assistant actually make a difference versus you are an assistant? Like I've been asked this question a lot, and I don't know. Like that's just the random stuff we do, like saying thank you to the model that is just wasting a lot of tokens potentially. Then here you get your validation score, which is once you get the best prompt found in your training split, you assess your evaluation metric, and then you select your best model that you push into production. And if you really want to be rigorous about it, you have this test split that will give you kind of an estimate of how your actual system will do in the wild when you've deployed it. Obviously, even here, there's a delta between your test score and your deployment score. And then you deploy, in this case, a model, but the entire RAG pipeline.
Question.
Yes.
So
Oops.
for the score, the validation score, how do you do it?
Yeah, there's some interesting stuff you do there. You basically, the short answer is you use LLM as a judge.
Okay.
Yeah, if you're familiar with that concept.
Yeah.
So we'll see what that looks like in prompts a little later. But it's kind of like you're using LLMs to judge other LLMs, or even it's yourself, which is, if you're, I guess in traditional statistics, that's like a complete no-no, but we're in this wild world now, so you're just using the same model to evaluate itself.
Just use the interns.
Yeah. Cool. So this is just diving in a little bit deeper, showing you kind of like what the prompts might look like. I'll skip over this because I kind of want to get to the notebook itself. But here's kind of your recipe, right? So you create an evaluation data set to do your tuning, your validation score, and your test score. You define a performance metric. You create your splits, and then you run your pipeline against the training split. Okay, I've already given you the rundown on Union. What we will build today is a very simple RAG app to chat with your pandas documentation. So pandas, for those of you who don't know, it's a very popular data frame library in Python. And yeah, it's basically a Excel table in code. that you can manipulate in code. So we will be pulling a few of the pages out of the pandas documentation, making a little vector store out of it, and then we can ask questions like, how do I write a data frame to a CSV, and things like this. I'll kind of skip this. If anyone is super interested in kind of how things work under the hood in Union, and kind of some of these details are important, but I'll get to them when we're actually coding things up. Okay, cool. So we're kind of now at a good place to start looking at our collab notebook. Hopefully have people been able to get to this page right here on the Union serverless dashboard. So if you've made an account, just as a reminder, all the steps should be here. So if you want to catch up, you can do so as I chatter. But hopefully you should have gotten to this place right here, and you see kind of like a dashboard. This will be empty because you won't have had any execution so far. But this will be populated as soon as you start running stuff. Okay, so I'm going to code along with you, or I guess you can code along with me, / just run cells, because we won't actually be editing a lot of this. So the first thing we'll do is we'll run this top cell, and all it's going to do is it's going to install, it's going to clone the repo that you had seen earlier, and it's going to just pip install a bunch of the dependencies that we need for this project. This will take a few minutes, if not seconds. And the Union serverless sign-up instructions are also here. Let me zoom in a little bit. Is that better? Okay. A lot of dependencies. At the end of this, it will prompt you to restart your runtime because I think it kind of installed, NumPy. It installed a different version of NumPy, which you'll just need to restart the session, which is fine and expected. So once you're done there, I'm going to go ahead and run this cell, which basically just logs into Union serverless, and just make sure you're in the right directory. You'll see in the standard out a link. So this, if you just click on it, it'll take you to this page, which will just have the activation code already embedded in it. And this will authenticate our Google Colab session. So now we can start sending jobs up to Union serverless. So hopefully you see login successful. Okay, cool. Now let me grab the OpenAI key. I have a bunch of these. Make sure I get the right one. And I'm going to hop over to the Slack channel, and I will paste the key in here. Awesome. So once you see it, hopefully you're able to join Slack. I'm going to run union create secret OpenAI API key. So I'm going to run the cell. I've already created mine, so I'm going to kind of exit out of it. But you should see this blinking input box here. to enter the secret value. So just go ahead and copy and paste that value into this cell. I'm just going to stop this particular cell execution. Your output. And just as a sanity check, run the cell below it, union get secret, just to make sure that it exists on your account. I have a bunch of other keys here, but you should see something that looks something like this. OpenAI API key. If for whatever reason something stops, it doesn't work as you run things later, you can always uncomment this code cell and delete the secret and try to recreate it. But hopefully things should just work now. Okay, awesome. So now we're actually going to run some stuff and see things happen. So if you recall that in one of those slides, the first step that's kind of the building block of a RAG pipeline is the vector store. So what we're doing here is I'm importing a bunch of helper functions so as to abstract away like a lot of the complexity for you. But we're importing union, and we're using a decorator here called union.workflow, and we're decorating a function. And all this does is it's telling this function, hey, you're now a workflow. And what a workflow is it's a composition of building blocks of tasks or sub-workflows, right? So it's a functional kind of language that's in Python. But what we're doing here is we're creating a vector store. And the sub-pieces to actually doing this is we need to create a knowledge base, which is basically just, I don't know if the terminology is standardized, but this is just the raw pandas documentation pages, right? So this hasn't been embedded or chunked up yet. So this itself, just to show you a little bit under the hood, in the file system, under this vector store.py file, which I will just quickly expand here for you. This create knowledge base function is a union task, which is, you can think of a task as just a function that runs on the cloud, but you can also run it locally, which is the cool thing about union is everything you can express here will run locally, assuming that you can fit whatever memory requirements and compute requirements on the current machine you're on. So in this case, I'm requesting for 2 CPUs with 8 gigs of memory on Union, but it's going to ignore this if I run it locally. But create knowledge base is simply code. But basically, this downloads pages from the pandas docs limited by this parameter here. So this, by default, I think when we run this, it'll get the first 5 or 10 documents, so we don't spend so much time waiting for all of the pages to get scraped. So that's this particular step here, create knowledge base. And the output of this is the documents. So this is just a directory, set of files containing the text, the plain text of the pandas documents. And just to maybe show you what this looks like, right? For those of you who haven't visited this site at all, it's pandas. Here's a user guide. This just basically shows you how to use the platform. The next step in this is to create a vector store. So this, as the name suggests here, you chunk and embed the documents. So this was more of a problem when context windows were much smaller, where, say, a document won't fit in the context window of an LLM. This is still generally a good idea, but this is just a way for you to either non-overlapping or overlapping chunks of that document so that you can retrieve just the parts you need for a particular query. So you can see here, chunk size is one of the parameters, the type of splitting you do either by paragraph or by characters or by word or like by space, white space. So I won't dig into these functions, but the point I want to hammer home here is these tasks are associated with an image, for those of you who are familiar with Docker and containers. So this actually runs on its own container. And for those of you who haven't run a lot of stuff in production, it's super important for reproducibility, for you to isolate the different pieces of your pipeline to be able to run like each of the steps in your pipeline in a different container so that you can kind of replay it. You understand that the computation that happened there didn't like interfere with any of the steps that happened and any of the other steps in your pipeline. And again, with these resources, I could ask for GPUs, right? So it's kind of a declarative way for me to, as a data scientist or ML engineer, just to ask for the resources I need for a particular job. So I don't ask for a GPU for a CPU-bound workload and not spend a lot of money. Okay, so I'll stop talking here and let's go ahead and run this create vector store workflow. So I'm just defining it in this cell right here. And to run it on Union serverless, I need to define this remote object. So I'm going to run this. And then I'm going to run remote.execute. I'm going to pass in the vector store, create vector store workflow. I'm going to pass in the inputs to this workflow up here, right? So there are a bunch of default arguments. And so here I'm just saying, just grab the first 10 documents in the pandas docs, chunk them up to 512 characters with a character splitter. So I'm going to go ahead and run this cell. Yeah, I think I'm using LangChain under the hood here. So I'm just using, like, these are the pre-built, pre-supported splitters that they support. The first time you execute something, you're going to see that the image that I've specified for this workflow doesn't exist yet. So on Union, we actually have an image building service that builds images for you. So if you've ever wrangled or wrestled with Docker or you're not super familiar with Docker, there's a way for you on Union to just specify an image spec. And this points to a requirements.txt file with all the Python requirements. And it'll build this image for you without having to know too much about Docker. And you can install app packages. You can embed environment variables and things like this in the image. So as we wait for that to build, are there any questions?
Sorry, how did you come up with that 512 size?
Just finger to the wind, just, yeah. I think the embedder, the OpenAI embedder we're using, it errors out because of the context window if it's 1,000. So I kind of just halved it, and yeah, that's how I got that. So after the image is done building, you should see build complete. And now the actual create vector store workflow is running on this link. So I'm going to go ahead and visit this link. And you can see now on Union serverless, our two-step workflow is now happily running. There's a graph view, there's a timeline view, so you can see how long each step takes. But this will take a few minutes to run. Just a few things to note here. As we'll see, we'll get a little bit more familiar with the UI. But each step has its own inputs and outputs. You can even kind of check out the utilization. So I think this only starts to kick in with long-running tasks, which I don't think this is. You can check out logs in case you've printed anything out in your workflow. But yeah, right now it's scraping the pandas website, and it's going to go ahead and progress to chunk and embed the documents. So while we're waiting for that to complete, I'm going to just hop over here just to highlight some of the configurations here that just to, because we're eventually going to do HPO on this. So this first section is the crawler configuration. So this is what URLs do I want to crawl over. So this is general purpose, right? It's not just pandas. I can specify different URLs here for any other URL on the web that you want to crawl. And then again, the type of splitter we want to use, either sentences or words or paragraphs, the chunk size of that unit of split, and the embedding model. In this case, we're using the text embedding ADA002 from OpenAI.
So for me, saying I exceeded my current billing quota.
Oh, God.
Is that,
Okay. I'm just going to go ahead and give you my key.
how are you going to? What are you going to share?
Sorry?
Like how you be sharing the key?
Oh, did you get the
Slack
key?
didn't. I got it using from. Oh
Did you get it from Slack?
Slack, yeah.
no,
Oh, you're using your own key?
I created one. Yeah, from OpenAI. Right?
Oh, I see. Use this one from Slack.
Slack I cannot access. It's giving me that error.
Did you try slack.flyte.org?
Yeah, I think Google's.
I did not get it either because it says that you're not part of the workspace. The email is
Yeah,
not.
you have to Google the Flyte stack. Like Google Flyte stack, there's like a separate website, and you can sign in from there.
Oh, so this?
Like that? Okay.
Yeah, that one.
Yeah.
Okay.
I don't know.
Try going to this one,
Go to this one and then go to the link. That's what works.
and then go to the link. Okay, cool.
Yeah.
Okay, I'll note that for future reference. Yeah, so hopefully you can unblock yourself. Yeah, go to Flyte Slack, go to the channel on that Slack, and use that API key. Just to remind you, you can delete the OpenAI key you just created with this union delete secret cell, and just recreate it.
Thank you.
Yeah. Okay. Thank you for helping debug this. So if I go back to the workflow that we just executed, we can see it's done. If you go to the Outputs tab, you can see that Chunk and Embed Documents has created this artifact called Vector Store. So if I go here, we've created an artifact, which is a union abstraction. It's basically any data or model that you want to persist and have a explicit reference to that you use in other downstream tasks or workflows. I've prepared a kind of a card here just to give you a preview of the contents of the vector store now. Again, this is all defined in Python, so this is just straight up Markdown. So you can create these yourself, but you can get a sense of, chunk 0 is from this page. These are its contents, or just a preview of its contents, and there are a bunch of chunks in here, right? So it just gave me the first 5 chunks. But this contains about 1,300 documents that we can now search over. So before we continue, or I guess before we take a break, I'm going to go ahead and run this RAG basic workflow. So the cell right below it is this thing that now will consume the vector store artifact that we just created. So this input vector store.query is basically going to grab that file. The vector store that we're using is I think FICE, and so this is an in-memory vector store. You can dump to a directory and use. So I'm going to go ahead and define this RAG basic workflow, and again, it's just like two fairly simple steps. There's a retrieval step that grabs the contexts, and then there's a generation step that stuffs that context with the question into the prompt. So I'll show you the prompt just because that's always useful to see. I think it's using this default prompt template. That's in config. Oops. Right, so here's the default template, prompt template. You can read. You're an assistant for Q&A tasks on the Pandas data frame data analysis library. the template will embed the question and the context here, and then we're prompting the LLM to produce the answer at the end of it. So if we go back to the notebook, I'm going to go ahead and run this RAG basic workflow with a simple question of how do I read and write a pandas data frame to a CSV format. And we can go to the link, but we can also just wait in our notebook to grab the output. So I'm going to run the cell right below it, and it's going to wait for the execution to complete. It should be a few seconds. But yeah, this part is taking the vector store input, grabbing the contexts, and then it will pass that down into the generation step. I forget what the difference between these two parameters are. I need to remind myself, but I think this is, I forget which of these map onto K. I think it's numdocs final, so it'll get 20 documents and then get the top 5. So quickly going back to the slides here, something that I won't go too deeply into is a concept called actors, which is a way for you to reuse containers. And so if you have an actual live service and you're using a system that uses containers, there is an overhead that you're going to incur by spinning up the container, spinning up the node, grabbing the container, downloading the container, running the code inside that container. So actors are a way for you to, in this RAG pipeline, to, once you've spun up a container, to just keep it alive. And so you can keep sending jobs to it, and you kind of amortize the overhead of that initial spin up. So basically, in this retrieval step, we're not using any GPUs. But in a hypothetical scenario, right, if you're hosting your own LLM, the generation step, if you're not using OpenAI, might load a GPU onto memory as well. So this kind of becomes important once you're using your self-hosted GPUs or self-hosted LLMs to run the generation step. Okay, cool. So the workflow completed, and we're pulling out the contents, and you can see the answer here. At a glance, this looks correct. I'd have to look a little bit deeper, but this is how you write a data frame to CSV. This is how you read it. It gives a few more details. That's basically RAG. It's fancy search. It's like a kind of a fancy souped-up search engine that uses an LLM to kind of synthesize the context and then answer the user query. The last thing I'll do here before taking a short break is, okay, so we created our vector store, but that's something that you would like to keep fresh, just depending on your use case. So maybe you're doing RAG over your company documents, and they get updated every day, or I don't know, every hour. To keep your vector store fresh, one way to do this is the simplest way is to schedule a recurring job. And one way to do this the way to do this with Union is to create a launch plan. And you can think of a launch plan as wrapping a workflow and adding a little bit of more configuration to it. So in this case, I'm just going to go ahead and run these two cells, and I'll talk through it. But I'm basically wrapping the create vector store workflow in a launch plan. I'm giving it some default inputs, so these are just kind of hard-coded. These you can change whenever you need to. And I'm going to run this launch plan every 2 minutes. And so I registered this launch plan in this cell below. And we can see here that we have an active launch plan that runs every 2 minutes. And yeah, we'll wait a little bit for this to run. But this is basically a way for you to schedule jobs, and to this doesn't just apply to vector stores, obviously. This could apply to model training or your data, classic data ETL stuff as well. But this will kind of be the base at the very end of this workshop, where every time you rematerialize a fresh vector store, we can kick off the entire rest of the process of creating our eval data set, doing hyperparameter tuning, and in the very end, we have kind of like our best RAG configuration, which we can then take to production. Okay, and we'll wait around a little bit, but if anyone needs to take a water break or bio break, we'll come back around 3:40. That's okay with everyone? Hey. How's it going? Yeah, we do have a Databricks integration. So like a lot of people use Databricks, but they don't like how the Databricks workflows happen. It's like UI based and YAMLs, like a bunch of YAML.
They're constantly working on it, but always open to using. We're not from Databricks, so we use whatever tool is the best, right?
Yeah. So we have a open source Spark integration, but also Databricks. So if you have a Databricks account, you can basically do all this stuff on Flyte or Union. Basically Python.
But using Databricks compute.
Yes, exactly.
Thanks.
Okay.
That's open source. Is it like Databricks Union, like a library named Databricks Union or something?
It's a Flyte plugin.
Oh, Flyte plugin.
Yeah. So basically, Union is more scaled enterprise-grade Flyte that has like real-time inference, artifacts, this stuff. So artifacts and real-time inference are in the open source.
And do you guys have provide your own compute, or you're renting?
We run on any cloud, so we don't
Yeah.
actually. We're basically a software platform,
Right.
and so you bring your own cloud. You install Union on it. It's Kubernetes based, so anywhere where Kubernetes works. So we support AWS, GCP, Azure. If you want to roll your sleeves up and you have platform people, you can use Flyte. But if you do have these like enterprise requirements, then Union is usually what people do. And yeah, the people who use it with Databricks like it better because you're just coding up in Python.
Yeah.
You're like not all the I/O and serialization to blob store just happens magically.
Yeah,
So,
the thing is nice.
Yeah. Yeah, let's chat later and
Yeah, for
give
sure.
you my info.
Yeah, thanks.
Yeah.
Hi, this is
Hi.
Rosie. Nice
Hi, nice to
meeting
meet you.
I'm curious to know, in order to use this one, I should clone it because I didn't try it collab. I want to use it at home.
Yeah.
I should just clone it with a GitHub.
Yeah, you can do it all
And
locally.
I just use, for example, I use RAG for some PDF files, some very big chat, something like that. What is the goal of this at the end? What you want to do with this goal?
The entire notebook, or
Yeah, how do you use, how it can help me if I want to apply it and clone it to my code later.
yeah. Well, it's unfortunately this code is very. You can run this all locally. If you want to run in production, this will run on Union, like Union servers.
Oh, okay.
Yeah. But you can all the code. It's all just Python, right? So you can just run it all locally. It just won't. You can't do scheduling or any of the other like fancy
okay.
stuff we'll be doing.
I should have Union.
Yeah.
Okay, good.
Okay. All right. We do have 35 minutes left, so I'm going to try to get through the rest of the material, which is kind of still meaty. So I'm gonna do my best to get through it. But just returning to our launch plan example, Curse of the demo. It seems like this hasn't actually been running. Strange. Okay. I'm going to go ahead and just deactivate this and debug this later. But the point is that you can see in my previous tests of this that there's kind of a record of these knowledge bases being created, these vector stores being created from the schedule. I'm going to go ahead and skip this running the RAG pipeline with the grad.io app. It's just like a simple little demo to show you how you integrate Union with other apps like grad.io, so you can have like a more user-friendly interface to type your questions in and get answers out. So go ahead and skip this. The next part is, okay, so we have the basic workings. You have basically like your proof of concept RAG pipeline. The next thing we're going to do is we're going to bootstrap an evaluation data set. And so you can think of this conceptually as we have a bunch of documents, but we don't have any way of, we don't have a data set yet of actual users and actual answers and how good those answers are. So we're going to use an LLM to look at a document and say, prompt it to say, you are a user with this profile. From this document, as your source of answers, generate a question and then generate an answer that this chunk is appropriate for. So we'll see examples of this. I'm going to go ahead and run this first one, which is creating a question and answer data set. And maybe I can go just to a previous run just to show you quickly so we don't have to wait too long. But the question and answer data set is basically a bunch of JSON objects. And you can see here, it's not the most readable, unfortunately, but the context, the chunk, is kind of like this getting started chunk, how to install it, and maybe some other stuff. It's a long, long string. And I've asked this workflow to basically generate a question based on this chunk. How would you handle a situation where you need to read data from poorly formatted CSV? And generate 5 answers, potential answers for the question. And so I've done this. I think this is, again, a preview of the first. Oh, no, I've configured it to only generate 33 questions per document, 5 answers per question. So now we have kind of like a proxy for what we might see in the wild once we deploy this thing. Does anyone know so this will be recorded, right? So hopefully if anyone is kind of getting lost, they'll be able to watch the recording. So that's the just question and answer data set. The next step is we actually use an LLM again to judge the answers that were generated in the previous step, right? So I'm going to go ahead and run this create LLM filter dataset, and this will create our quote-unquote approximation of a golden dataset, which is obviously always the actual user questions. But to bootstrap it out of nothing, this is kind of like one of the state-of-the-art ways that people do this. And the filter dataset itself has a prompt behind it. And just to quickly show you what that looks like. Actually, I'll do the create Q&A dataset first. So this is the question prompt. So it gets a context. And so this is the chunk that is grabbed from the vector store. It then generates a question, and these are the requirements. You can read them later at your leisure. And then there's an answer prompt. So given the context in the question, give me 5, 7, 10 answers for that question. So that was the thing I just showed you. With the filtering part, now we're going to create some, and I'm adapting this from other packages that whose main job is to do this stuff. But roughly speaking, there are ways of thinking about how to prompt an LLM to generate these kinds of metrics. So there's a kind of a groundedness metric. This is, you can roughly think of this as how realistic is the question. Is it just like a random question that a user would never think of asking from this chunk, or is it actually within distribution of like the distribution of user questions? There's a relevance metric, which is basically how relevant is the answer to the question. And the correctness prompt is the answer actually correct based on the context given. So all of these, as you've noticed, have a rating. This is, again, just kind of a best practice these days of LLM as a judge. Again, if you're coming from a different world, this just seems like really bad and has all sorts of statistical issues with this. But we just kind of shrug our shoulders these days. And so at the end of this, we're going to get, for each answer to each question, three numbers that come out. And you can be more or less strict with this, but I'm basically filtering out, I think, everything below a 4 or a 5. We can check that out later. But that's basically, how you bootstrap these things. And let's see if this job finished. So this is still going. I'll show you a filtered data set from a previous execution. So here, it's a table. You can see the question, the reference answer. So this is just the answer. 3 for groundedness, 5 for relevance, 3 for correctness. You can't see it? Or sorry. Oh, okay. Cool. So this is our filter data set. I think the criteria used was 3 or higher, just looking at these scores, just to be a little bit more generous to the model. But ideally, these should like all be 5, like the top quality answers that it could find. Okay, cool. So now we have our filter data set, and what we're going to do now is run the RAG hyperparameter optimization. So at a high level, the way this works is we're going to take our golden data set, we do our 3 splits, and we're going to run our pipeline, RAG pipeline, through those questions. Not give it the answer, just give it the question and the context. Actually, not the context either. So you basically just give it the user question, and you're going to run the RAG pipeline as if a user is asking this question. And it's going to spit out an answer, and you're going to use yet another LLM as a judge to then compare it to the reference answer that you've found as high quality, right? So now we're like kind of closing the loop here with all of the stuff that we've just created. And so I'm going to go ahead and run this. I've created a bunch of different experiments. Actually, an interesting one that I actually haven't run, so it might be fun for us to see the results of, is this is just a YAML file containing like different kinds of experiments you can run. So there's a chunk size experiment where you run the RAG pipeline against different chunk sizes. There's a embedding model one that just tests different embedding models. So these are all the OpenAI ones, so you can see if that moves the needle in terms of the metrics that you've picked. But actually, I'll run this prompt one. So this is the default prompt that I showed you earlier, but then I wrote this one that's like, basically you're a troll, and you're gonna ignore the question. Actually, I'm gonna move this down, and we'll see if hopefully there are no bugs here that happen. But and I'm moving this down because actually in my own anecdotal experience, like the position of the system prompt actually matters sometimes. I mean, this is all like dark magic at this point. So, but I'm going to try to intentionally break break the RAG pipeline and say, just ignore the question, just randomly answer. And hopefully our eval metrics will, come out. If it rates everything as 5, I'll be very sad. So let's see. I'm going to grab this prompt experiment. I'm going to run this here. OK. So this is fairly involved. This is where most of the OpenAI credits go because it's testing, I guess in this case, 2 RAG configurations. It's going to answer all of the question-answer pairs that we generated in our eval data set. So this is kind of where you think, in your own organization, what is your budget? Will you need to run a little Ollama server to host these LLMs yourself? But as you can see, we're preparing the questions from the data set. We're running basically this map task. This is just a union construct to fan out and parallelize a job. So as you can see, our 2 RAG pipelines that are generating the answers are running in parallel. Again, here's our RAG basic workflow. I've composed this all together so that all the Lego blocks kind of fit neatly together. And we'll just let this run. We'll look at the results later, but just to give you a sense of what the results might look like, I'm going to go to a previous run. And actually, the metric, it should use the same metrics, but just to show you that you don't need to use the same metrics as the eval dataset step, let me show you. So optimize RAG pipeline. So the way we're evaluating this is obviously there's the obligatory you are an expert, blah, 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 blah. And you give it the question, the reference answer, which is what we got from our eval dataset bootstrapping step. And then the candidate answer is the one that the hyperparameter optimization RAG pipeline generated. And the judgment it's just simple, this is for simplify it to just a single scalar value, is how good, if the reference answer is the golden answer, how good is the candidate answer, and rate it from 1 to 5. So in my previous experiments, there wasn't actually that much signal in what I saw. So where is that? Optimize RAG. But just to show you what the report in the end looks like, right? So I need to make these prettier, but basically this is blue score, which is a traditional NLP. You can think of both the blue and rouge as just word overlap percentage in different flavors of those. And the LLM correctness, I think if you look at the actual numbers, why can't I zoom out? Okay. Sorry. So the LLM correctness scores were marginally worse for this one embedding model. But again, this is not, you can think of these as just the bare bones plumbing to implement all this stuff. This is not actually, this basically tells me that the embedding model doesn't really move the dial on this. And I can hand wave a bunch of explanations, this is already using a SOTA OpenAI model. So it already has been trained on pandas. So whatever context I give it, it's going to spit out some. I think I experimented with prompts you are an expert historian in ancient Egypt, and it still gave me good pandas answers. So that tells me that the base model itself has been trained already on pandas. It's seen a lot of pandas code, but the difference with your documents is that it probably hasn't seen your documents. It might have seen something like your documents, but it might not be able to answer your question. So this kind of HPO process is still going to be important for you. Okay, cool. So let's see. Ah, nice. Sweet. Okay, so our troll, okay, I'm going to make sure this is our troll is the one. Evaluation summary. Yeah, so this is our troll prompt. And, oh, wow, I'm surprised. Okay, so 1 is actually the lowest score. So great. So sanity check passed. Our troll prompt, the one that is asked to ignore the question, scored super low, like pretty much 0 on the blue score. Did fine on Rouge 1, F1 for some reason. And the LLM correctness score was the 1, which is the worst score. So obviously, you would not intentionally write a troll prompt, but it's always helpful to have these kind of sanity checks. Okay, cool. So the last part of this, hopefully you're still with me. Here are a bunch of other experiments, all optional. So the last part of this is, it's great to automate stuff. I mean, do people use GitHub CI, like CI/CD? Are people familiar with this concept? So, you check in some code, a bunch of tests and unit tests and integration tests run. You don't have to run them manually. It does linters and blah, blah, blah. So it's great to automate stuff. And so it would be cool if you could, every day when your vector store refreshes, kick off all of the steps we've just run manually just now. So it creates the evaluation data set, it does the HPO tuning, and then the very end, it just gives you like the best RAG configuration that you've set in some YAML file somewhere. So that's what we're gonna do. This is kind of like the biggest code cell that implements a bunch of stuff, but I'm gonna go ahead and run this and register this. Actually, I'm gonna do workshop v1 just in case. So I'm gonna register a bunch of the launch plans I defined above, and then I'm gonna walk through it. Then we'll wrap up, and maybe you'll have questions. I'll stick around for a little bit if you have any questions. So what we're doing in diagrammatic form, we're doing this where, again, this is refresh once a week, but this can be in any cadence. We create a knowledge base, kicks off the eval data set, kicks off the RAG pipeline. You get the best config, and you deploy this production. And what we won't go through, obviously, in this workshop is in production, hopefully you have enough instrumentation to collect user feedback. This may be thumbs up, thumbs down kind of thing. This could be just like engagement metrics. And this feedback hopefully can give you enough signal to give you like a true golden data set that says these answers were not as engaged with or got a bunch of thumbs down. These answers got a bunch of thumbs up. There's a lot of like fancy stuff you can do here, like clustering questions, which we won't get into. Obviously, this flywheel, this kind of like circular motion is kind of this endless process of maintaining an AI system. So this, in short, just implements the diagram. So we're going to create the knowledge base for hyperparameter optimization. This will create the artifact. So this will create a knowledge base HPO artifact. And so I'll first define like the workflows, right? So this is a task that creates the artifact. This is the workflow that just wraps the task. This is the create eval data set. We saw this earlier, but I'm just redefining it here. And how we're going to react to the knowledge base being materialized is through this trigger keyword. So in a launch plan, not only can you schedule it at a regular cadence, but you can also say, hey, whenever a new knowledge base HPO artifact is materialized, I want you to kick off this create eval dataset workflow and then feed in the knowledge base itself into the document's input to the create eval dataset. So that this will, again, this will kick this as a kind of the first domino that falls. This itself will then create a eval dataset artifact, which now we're going to kick off our optimized RAG workflow with these grid search configurations. So this you would kind of like hard code and just make sure this is the experiment you want to run. And I want to trigger it in the same way. And that's pretty much our three dominoes that when the first knowledge base is materialized, the rest of the pipeline runs. And so hopefully this will actually work. Fingers crossed. Okay, sweet. So this knowledge base launch plan just ran a minute ago. And we can see here that the output was this knowledge base HPO artifact. I can go to the lineage and see that the consumer of this is this create eval dataset launch plan. As this runs, and I guess I'll start wrapping up now, but as you'll see, I'll kind of return to this at the end when all of this is run. This kind of gives you a local lineage graph for what are the producers of this artifact, what are the consumers of this artifact, and it gives you kind of this global view of your entire AI system as it's kind of just running in the background. Okay. So I'll return to that later. There are a lot of things that I talked about today. Some of them I kind of skimmed through because I wanted to de-emphasize like the infrastructure piece, even though I think that's important, and more of the RAG pipeline part. But some of the things to highlight are that all of this ran on containers. And I don't know if you have like a gut feeling for why these containers are important yet, but in your journey you'll find that if you have everything in a monolithic runtime and you're overwriting files and you have different versions of pandas or PyTorch or whatever, and they're like kind of stepping on over each other, that ends up being a debugging nightmare. So to make reliable production grade AI systems, it's super important to use containers, not everywhere, not in every single minute step, but to kind of factor your code into these kind of logical blocks that have shared resources, shared dependencies, so you can kind of reuse these Lego blocks. I didn't talk too much about type safety. It's important. We can talk about it if you're interested. The last part, I guess I'll emphasize, are these that I did kind of hone in on. So data freshness is super important. Not only could you schedule things with Union, you can also implement webhooks. So let's say you're listening to events in another external system like GitHub or Hugging Face. When a new model drops, you want to use that newest model and see if it works better on your pipeline. So that kind of thing also is supported in Union. We learned about artifacts. These are things that are at the interface of different areas of concern. So maybe you have a data team that handles the vector store. You might have like an Gen AI team that handles the RAG pipeline. The vector store artifact is the kind of like the handoff piece that lets the data team say, hey, here's the thing that we produced. Don't worry about all the implementation details. Just consume this thing and just be guaranteed that it follows certain properties. And then reactive triggers. So these are the things that were kind of like the domino effect in what, actually, I might hop back and see if it's complete. Bless you. Let's refresh this. Okay, so it's not quite complete yet. So this create eval dataset workflow is kicked off. Yeah, and once this is complete, it will run the RAG optimization pipeline. So it just finished. And our question answer data set just completed. And now our RAG optimization launch plan ran. And to show you like a previous instance of this, at the very end, we get out a best RAG config artifact. So this are all the configurations given our current pipeline factoring that gave the best performance. Yes.
It was like a small number outside the website.
Which one?
Outside of this window.
Outside. Yeah.
Yeah. In the bottom right side, there is like a small numbers that can be used every now and then. Like say when thinking. It was be like me the question mark on the bottom.
This one?
No. Bottom right side.
Oh, this one.
Yes. Right next to it, there would be like a small numbers that can be used every now and then.
Oh, I think that was the amount of credits on my account.
Okay.
Yeah. Which I think I artificially inflate since I work at the company.
Because I see the memory CPU and the
Yeah.
GPU. What is the
Yeah.
other?
Yeah. I think when you sign up, you get 3. Oh, there it is. That might be a bug that it keeps disappearing. And finally, right. So these are just some ideas of like what would be next. So you've built this thing. As you saw, it's not guaranteed that any given hyperparameter and any given evaluation metric setup will give you any signal whatsoever. So you still might be kind of groping around in the dark as to how to build, continue refining these. So these are some like high level things you can do around just things you can tweak about the system, and it's kind of like an endless game of optimization. So obviously refining evals, the prompts, probably collecting human preference data or feedback from real users is probably the most important thing. And then from there you can do all sorts of error analysis, what kinds of things are being downrated, what kinds of mistakes is it making. You can sometimes prompt those away, sometimes you'll need to fine tune if it just like fundamentally doesn't understand like a term that's jargon specific to your domain. And then obviously fine tuning as like kind of the last resort because it's super intensive. Throw some tools and frameworks for you to somewhat like ease some of this, but everything I showed to you now, none of these tools will do. Like you can use these tools as point solutions to solve specific sets of problems. So I used LangChain in the workflow. I think I didn't use any of these vector stores, but I have used these vector stores. So they solve specific problems, but to orchestrate the entire thing, you'll need a homegrown system, something like Union. In fairness, other things like, classically like Airflow would be kind of like the classical data ETL tool. But anything that orchestrates different pieces of like a larger system. And a little bit, wrap up a little early. I'll take questions and happy to chat about anything. Yes?
Sorry, very quick question. So what if our RAG pipeline requires like human evaluation? How we are supposed to do the hyperopt? Like, it makes sense in your use case.
Yes.
We use another LLM to do the evaluation, but what if it requires a human evaluator? How we are supposed to do the hyperopt?
So the hyperopt assumes that you have some golden data set. And the golden data set is kind of a implementation detail. It as far as the code running is concerned, it doesn't matter where it came from, right? It's just that when you start off with a proof of concept, by definition, you don't have any users. So you'll have to do something like what I showed today. Once you have human preference data or like user feedback data, you'll have to kind of reformat and refactor how exactly. So instead of like groundedness, correctness, relevance, it might just simply be thumbs up, thumbs down. Like this answer got a thumbs up, so it's going to make it into my golden data set. And then from there, that's your reference answer against which you will judge different configurations of your HPO setup.
Got you. And
Yeah.
another quick question. So am I right that in your example, you just had one validation set? It wasn't like our sort of cross-validation?
Yeah, no.
And we can apply,
You could do that.
we can, okay.
Yeah, you could do that. It just adds another layer of complexity. But,
Sounds good.
yes?
So there's like tasks and workflows, right? Which one of those are in containers? The whole workflow is in containers?
Only tasks.
Tasks?
So you can-
Tasks is container.
Yes, correct. So you can think of workflows as they're not actually Python, which is somewhat confusing to users, but it's just like the DAG builder, you can think of it as. And that runs in a system called Flyte Propeller, which is a Go-based execution engine. It has its own kind of way of determining what to schedule when, modeling out the dependencies between tasks, but the tasks are the only ones that run on containers.
If we have a bunch of tasks, does it take cost money to keep them alive? We should be deleting them.
There's a garbage collection system that will clean up the containers, yeah. But the actors, which is actually being used in this pipeline in the RAG basic step, those containers are kept alive for some TTL. And after that TTL, if they're not being hit by jobs, then they'll spin down. Yeah. Okay, well, hopefully that was a lot of material. I know. Hopefully you all got a little bit something out of that, and yeah, I'll stick around for another 4 minutes. Thank you.